Hi friends, today we will learn how to sketch the graph, and this lecture will be useful for all the students who want to give IIT, JEE, Mains and Advanced. Let's see. There is a function fx equal to x. So we will look at all the aspects of this function. Fx equal to x. I know everybody knows how does this graph looks like. This is the line fx equal to x. What is the domain of this function? I can see the function is coming from minus infinity and going up to positive infinity on x-axis. So you can say domain is minus infinity to positive infinity, open interval always, or you can also say all real values. So domain is all real values. There is no point on x where the function is breaking or function is not defined. What is range? Range are all my possible y values. So I can see this function is coming from minus infinity to positive infinity. All y values are defined. So range in this case is all real values. You can also say minus infinity to infinity, open interval, or all real values. Let's understand one aspect of this function, whether it is an even function or an odd function. So what is an even function and what is an odd function? So any function which satisfies this condition is an even function. By putting minus x for x, if the function does not change, it is said to be an even function. Let's see. I am replacing x by minus x in the function. So I get f minus x value is minus x. What is my fx value? Fx value is x. Are they equal or are they not equal? They are not equal. So this function is not an even function. Let's check whether it is an odd function or not. So the condition for odd function is f minus x should be equal to minus of fx. In short, by replacing minus x in place of x, if the new function is negative of the original function, then this function is said to be an odd function. Let's see, let's find f of minus x. So f of minus x is minus x. I am replacing minus x in place of x. Okay, what is my fx value? Fx value is x and this is minus. Are they equal? So yes, they are equal. Hence, this is an odd function. Also friends, graphically if you can see, any function which is symmetrical about origin is always an odd function. What is the meaning of being symmetrical about origin? Symmetrical about origin means if the graph has gone in the first quadrant and if the symmetry is coming on the third quadrant, then it is said to be symmetrical about origin. Or any graph which is coming in, which is there in second quadrant and its symmetry is there in fourth quadrant, it is said to be symmetrical about origin. In this case, it is symmetrical about origin because the graph is in first quadrant and third quadrant, so it is an odd function. Graphically, what kind of function is even function? Those functions whose mirror image are along y-axis is an even function. Just to give an example, this kind of function, this shape is similar to this shape if I keep this as a mirror. So this function is an even function because the similar shape along this and this are existing. Okay, let's come to a new function. Let's say there is a function fx equal to x square. How does this graph looks like? It looks like a parabola which is passing through origin. What is the domain? X values are coming from minus infinity going up to positive infinity. So minus infinity to infinity is the domain, or you can also write all real values. What is range? Range in this case is the y values. So y values are 0 onwards going up to infinity. So 0 to infinity is the range. You can also say all positive real values including 0. So when you say real positive values, 0 is not a part of positive real values. So you will have to mention 0 as well. So this is range. We have to check whether this function is even function or not. Let's find f of minus x. F of minus x is minus x whole square, which gives x square. And f of x is x square. Are they equal? Yes, they are equal. So this function is an even function and not an odd function. Graphically you can see that this function is symmetrical about y-axis. All even functions are symmetrical about y-axis. All even functions are symmetrical about y-axis. The kind of shape on the right side of y, similar shape on the left side of y you will get. Let's come to next function. How does fx equal to x cube look like? So if you can have a basic knowledge of little of algebra, you can see that when x is increasing, y is also increasing. Also, when x is increasing, y is increasing at a higher rate. And when x is decreasing, y is also decreasing at a higher rate. So the graph somehow looks like this. When x increases, y resultantly increases at a higher speed, and when x decreases, y resultantly decreases at a higher speed. So this is how x cube function looks like. What is the domain? You can see from minus infinity to infinity all the values. all real values. Range is also all real values coming from minus infinity to infinity, all the values. Again, is this function an even function? So I can see that the function has gone in the first quadrant and the symmetrical figure is there in the third quadrant. So this function should be an odd function because this function is symmetrical about origin. Algebraically also, if I want to find f of minus x, I will get minus x whole cube, which is minus of x cube. Okay, let's find this part. Minus of fx. Fx is x cube. Are they equal? Yes, they are equal. So this is an odd function. Okay. Let's come to our next function, x to the power 4. Now here I will try to relate all my function of this pattern, whether fx equal to x square or fx equal to x to the power 4 or fx equal to x to the power 6 and so on. So my friends, we know x square looks like this. X to the power 4, can you tell me why in this case is increasing at faster rate or in this case is increasing at faster rate? So rate of increase of y is faster in this case. And when x value is more than 1. So rate of increase of x is faster in this case when x is more than 1. And if x is less than 1, then fx is increasing faster rate in this case. So if I say this is x square function, fx equal to x square, x to the power 4 will go like this. Can you see this point of intersection? This point of intersection is 1. Before 1, x to the power 4, y is smaller, and after 1, fx is greater than x square. So after 1 it is increasing at a higher rate, and here it is minus 1, and before minus 1 it is increasing at a higher rate. So this red graph is x to the power 4. Similarly, if I have to draw x to the power 6, it will go like that. So the blue graph is fx equal to x to the power 6. So all these even graphs look like this, and their point of intersection is always 1, 1, and this point is minus 1, 1. Now, what is the domain of this function? Domain of x to the power 4 is all real values. Range is all positive real values including 0. I am talking about x to the power 4. So x to the power 4 domain is all real values and range is all positive real values including 0. X to the power 4 is an even function because replacing minus x for x, function does not change. So x to the power 4 is an even function. Similarly, x to the power 6 is also an even function. Let's move on. Let's see how does fx equal to x to the power 5 graph looks like. So my friends, we had learned before how does fx equal to x cube graph looks like. It looks like this. So x to the power 5 graph, this is increasing at a faster rate than this thing after 1. So after 1, it will increase at a faster rate, and before minus 1, it will decrease at a faster rate. So x to the power 5 function is this. After 1, it is more vertical, and before 1 it is more horizontal, and it is like that. Okay. In the same graph, if I ask you, how would you draw fx equal to x to the power 7? So they all intersect at 1. Can you see? The blue graph represents x to the power 7. Now we can discuss domain for this function. So domain of this function is all real values, and range of this function is also all real values. Is this function even or odd? So I can see that this function is symmetrical about origin. The kind of figure we have in first quadrant, similar figure we have in third quadrant. So this is an odd function. Let's see. We have a function fx equal to 1 over x. This is a standard function of rational function. How does this graph looks like? If you can see, if x increases, y decreases, and if x decreases, y increases. Also, if x is negative, y is negative, and if x is positive, y is positive. What we said? We said 4 things. If x increases, y decreases. 1 over x decreases. If x decreases, 1 over x increases. If x is positive, this whole thing is positive, and if x is negative, y is negative. Okay. So considering all this, the graph of 1 over x looks like this. This is how it looks like. When x is positive, y is also positive. Means all the points where x is positive, y will be positive, and all the points where x will be negative, y will be negative. Also, x can never be equal to 0 because the denominator cannot be equal to 0. So, it is not touching y-axis because this is my x0, right? So, at no points on this graph, x can be 0. Okay, if I ask domain of this function, domain of this function is, you can see on graph, it is coming from minus infinity and going up to positive infinity, except this particular point. It's not that particular point, it's the particular line. So the graph is not at all touching this line. This line is what? X equal to 0. And this graph is not at all touching x equal to 0. This side either. So we have all the values of x except 0. So domain is all real values except 0. What is range? You can see the graph is coming from negative infinity. Coming from negative infinity, all the values except touching this line. What is this line? This line is y equal to 0. So the y values are everything except y equal to 0. Because this curve is not covering this line. So all real values except 0 is my range. Okay, I want to know whether it is an even function or an odd function. By looking at the graph, you can say it is an odd function because symmetrical figure is in first quadrant and in third quadrant. So it is perfectly an odd function. Also, let's talk about asymptotes. What are the asymptotes, my friends? Asymptotes are the lines which tend to touch the curve but actually does not touch the curve. So here, this line x equal to 0 looks like touching the curve, getting closer and closer and closer to the curve, but this line and the curve are never meeting each other. They are getting closer and closer and closer but do not meet each other. That is, this line x equal to 0 is called asymptote. Now this is a vertical line, so this x equal to 0 is called vertical asymptote. So in this function, vertical asymptote is x equal to 0 because this is the asymptote which is vertical. Also, I can see that there is another line y equal to 0 which this curve wants to touch but cannot touch. Okay, it gets closer and closer to the curve but is not touching the curve. You can see it is getting closer and closer to the curve but is not touching the curve. So the line y equal to 0 is the tangent to the curve at infinity, which actually does not touch the curve but looks like touching. Okay, never intersects. Gets closer and closer only but does not touch. So y equal to 0 is the asymptote and it is horizontal asymptote. Why horizontal? Because this is a horizontal line.